Good morning, students. Welcome back to this data structure class again. In the last class, we discussed about an application of linked list, that is polynomial addition. The same polynomial addition can be performed using array-based list. That's what we are going to discuss in this class. It is even more simple than polynomial addition using linked list. Here, we will keep a separate array for coefficients of the polynomial and a separate array for the exponents of the polynomial. Okay, here we will use the class. In the last program, we didn't use class. But in this program, we will use class. Okay, let us see. It is simpler. Class poly. Private. I said we will use here array for coefficient. Max. Then similarly an array for exponent. Then I want to know the number of terms in my polynomial, that is poly size. What is this max? I will define it as a constant. Okay. Max 50. Then public, the constructor poly, then I use a method for reading the polynomial, method for displaying the polynomial, a method for addition of polynomial. Okay, so void create, then void display, then addition. That's all. What does this particular statement means? Through an object, I will add a polynomial with the formal polynomial used here. Okay, this I will explain in the next few lines. Now let us define with these methods. Void poly containing create. I want to know the number of terms in my polynomial. See in poly size. Okay. Now I accept the coefficient terms and exponent terms for the poly size number of terms in the polynomial. For that, I use a for loop. For int I equal to 0, I less than poly size I plus plus I get the coefficient term and the exponent term. Coefficient of I exponent of I. That's all. Then I display the accepted polynomial. Void display is available in the polynomial class. So void poly resolution operator display for int I equal to 0, I less than poly size I plus plus. What I do, I display the contents. That's all. Just display what is the coefficient and what is the exponent is. Okay. See out coefficient of I plus exponent. Exponent of I. Coefficient of I comma exponent of I. That's all. My polynomial gets displayed when I call this function. Now we go for addition function. Now the return type of this addition function is poly. Recall what I told you about this class. A class is basically a user defined type. Okay, the output of this addition function is a polynomial. And what are the inputs? An object accessed through the polynomial, accessing the polynomial on this formal parameter. These two are added and the results are stored as an output polynomial. That's what we are going to do it now. Poly addition poly T. Okay. What does it mean? Add this polynomial with the object polynomial and give the output as a polynomial. That is the meaning. Okay. I use some local variables. I equal to 0, comma j equal to 0, comma k equal to 0, comma ps equal to 0. These are the local variables I need for traversing through the polynomial. Now, do now recall whatever I told you about various kinds of polynomial. Polynomials of equal size, equal number of terms. First polynomial having a higher exponent than the second polynomial. A second polynomial is having a higher exponent than the first polynomial. So these are the various cases that we should take into consideration for adding polynomials. Okay. So if exponent of I greater than t dot exponent of j see this I is for the first polynomial, j is for the second polynomial. That means if the exponent of the first polynomial is greater than the exponent of the second polynomial, okay, then the resultant polynomial will have the exponents of the first polynomial. That's what we do. So result dot exponent of the resultant exponent is equal to exponent of the first polynomial, that is expo of I. Just now I told you that I is for the first polynomial. That is, if the exponent of the first polynomial is greater than the exponent of the second polynomial. Similarly, what I should do, I copy the coefficient. Okay. Result dot coefficient of, the resultant polynomial is k. So the exponent of the resultant polynomial is coefficient of I. Coefficient of I. Then I just told you that I is for the first polynomial. Here we are considering first polynomial. So after considering the first term, then I should increase. I should go to the second term. So I should increase my I. So I plus. Then the resultant polynomial k should also be incremented. Then polynomial size should also be incremented for the resultant polynomial. Okay. Else if the second polynomial exponent is greater than the exponent of the first polynomial, that is, if expo of I is less than expo of j. Okay. Else if what do? I copy the second term's polynomial coefficient and exponent to the resultant polynomial. Okay. So simply I will copy this one to here. I make some minor corrections only. This is exponent of j. Then coefficient of j. Then it is not I plus plus, rather it is j plus plus. Okay. Else, that is, the exponents of the polynomials are same. Exponents of the polynomials are same. In that case, what I should do? I should take one of the exponent to the output polynomial, and the coefficient is the sum of the first polynomial and sum of the coefficient of the first polynomial. Sorry, the sum of the coefficients of first and second polynomial is the taken to the resultant polynomial. Else, result dot exponent of k is equal to any of this thing of I or j also you can write, and result dot coefficient of k equal to the sum of the coefficients of both the polynomials. Okay, that is expo of coefficient of I plus t dot coefficient of j, t dot coefficient of j. Then I should increment both this I and j, because I have considered the first term of the first polynomial, first term of the second polynomial. Now, similarly, I have to move to the second term of the first polynomial, second term of the second polynomial. So I should increase my I and j and k and ps. So I have taken into consideration all those things. How long it will go? Do while the when the number of terms of the first polynomial is less than polysize, and similarly for j, that is do while I less than polysize, less than or equal to polysize, and j less than or equal to temp dot polysize. So at the end of this do while loop, you would have added the given two polynomials. Okay. So result, the polysize of the resultant polynomial is ps. Result dot polysize equal to ps. That's all. Return result. So we have completed the addition function of the given polynomials. Okay. Now we have to write the main method. Void main poly P1, P2, P3. First polynomial, second polynomial, third polynomial. Create the first polynomial, that is P1 dot create. Create the second polynomial. P2 dot create. Then display the first polynomial. P1 dot display. P2 dot display the second polynomial. You know that object of a members of the class methods are accessed only through the objects. Here P1, P2 are the objects. Now I have to add all these things. Now we are going for a very crucial step. P3 equal to P1 dot addition of P2. I want to give you a greater attention to this particular statement. What is this addition function says? This T is for one polynomial, then there is an object polynomial. This object polynomial and this formal polynomial are added and given as an output to the polynomial. Now with that understanding, you see here through the object P1, I call the method addition. The actual parameter of this addition function is another polynomial P2. That means this P1 and P2 are added and the result P3 is stored here. P3 is equal to, okay. So the output of this statement is a polynomial. P3 is equal to P1 dot addition of P2. Then P3 dot display. That's all we have completed. Yeah, very simple program. See how a polynomial can be added using array based list. Okay, it is a very simple program. Just to recall what we have done, we have maintained an array for coefficient, we have maintained an array for exponent, and we have maintained a private variable polysize for this. And the methods are creation, display, and addition. Creation for all the polysize terms, get the values of coefficient and exponent of each term. When I is equal to 0, I get the coefficient exponent of the first term. When I is equal to 1, coefficient exponent of the second term. Like this, up to the polysize terms, I get the coefficient and the exponent. Similarly, display coefficients and exponents are displayed. Addition, we take into consideration all the cases of polynomial. That is polynomials of equal number of terms, polynomials of different number of terms, and exponents are differing like this. All the cases are taken into consideration. Then we go for the main. Here we declare three objects P1, P2, P3 of the class poly. So using the object P1, I create the first polynomial, and using the same object, I display that polynomial. Using P2, I create the second polynomial and display the polynomial. Then using the addition function, the addition function is called using the object P1, and the actual parameter of this addition function is the second polynomial. So P1 and P2 are added and the result is stored in the polynomial P3. Then P3 display. Okay, it is so simple. That is how it is declared. Okay. So we have seen this implementation. Okay. Rest we will see in the next class. Okay.